Hello students, in this video we are going to discuss the nucleophilic addition reaction of aldehyde and ketone. So in the previous video we discussed already about some of the concepts in nucleophilic addition reaction like mechanism of nucleophilic addition reaction and the reactivity of aldehyde and ketones in a nucleophilic addition reaction. Now, according to the syllabus, the chemical reactions of aldehyde and ketones which we need to discuss, these are first nucleophilic addition reaction, second nucleophilic addition by loss of water, that is can also be called as nucleophilic addition elimination reactions, oxidation reaction, reduction reaction, the reaction due to alpha hydrogen and some other reactions. So we need to discuss all these chemical reactions of aldehyde and ketones one by one. So in this video we are going to discuss about the nucleophilic addition reaction of aldehyde and ketones. So there are some of the reactions involving the nucleophilic addition reaction of aldehyde and ketones that we need to discuss. First one, the addition of a hydrogen cyanide, that is the addition of hydrogen cyanide means HCN. Hydrogen cyanide, that is HCN. So the addition of hydrogen cyanide with aldehyde and ketones that can be represented here in a carbonyl group here, because the aldehyde and ketones both have carbonyl group. If it is an aldehyde, you have to keep one R here and one H here. If it is, we are doing the reaction for ketone, at the time we have to keep one R here and one R here. If we are doing the reaction for acetone, we need to keep one CH3 here and one CH3 here. If you are doing the reaction for acetaldehyde, at the time you can keep one CH3 here and one H here. So that is depending upon what we have the aldehyde and ketone, you can frame the product. So better we'll be doing the general equation in this way. So here we'll be doing in this way, as we are already familiar that the carbonyl group in which the carbon which is partially positive charge, because the carbon is less electronegative than oxygen, and because here oxygen is more electronegative, therefore it develops a partial negative charge. That means the carbonyl group is a polar group having a partial positive charge on carbon and partial negative charge on oxygen. So the reaction with the HCN in this Cn negative, that is negatively charged. Because it is negatively charged, that means it is a nucleophile. That means it is a nucleophile which will attack the partially positively charged carbon of the carbonyl group in the aldehyde or ketone. Since the opposite charges attract, so we can say that the carbonyl group in which the carbon is partially positive, so the nucleophile which is negatively charged will attack on the partially positively charged carbon atom. So here there will be a formation of an intermediate when it get attached on this carbon. This Cn get attached on this carbon, so the bond, double bond will break and the electron shift towards the oxygen. It develops a negative charge on oxygen. So this is a formation of an intermediate here that is formed. Look at the reactant and product here, because Cn is get attached on this carbon, that you can see here. Cn is attached on the carbon and the oxygen is now it have a negative charge, because the electron of the double bond that is shifted or displaces to the oxygen. That's why the oxygen having negative charge here. Now here this is actually sp2 hybridized carbon. Now it turns to sp3 hybridized carbon, that is a tetrahedral intermediate which is formed. Now when one H plus is there, that H plus or proton, it will get attached on this oxygen because O is negatively charged, H is positively charged. So it get attached on this oxygen. So that result in the formation of a product that is called as cyanohydrin. So here the nucleophilic addition is taking place, that is addition of HCN. So how easily you can frame this product without writing an intermediate, that I will tell you here. Because HCN, that is partial, we can say that H have positive charge and Cn have negative charge. So the positive goes with negative, negative goes with positive. That means H plus, that is positive, it will get attached with the oxygen that is partial negative, and Cn is negative, that get attached on the carbon that is partially positive. So in this way you are getting this product. So without this intermediate, if you want, you can directly frame the product that is cyanohydrin. So this is a very important reaction. Usually the questions you'll be getting on this area, that is if any aldehyde or ketone is given and the reaction with HCN, that is giving rise to cyanohydrin. Here the name of the cyanohydrin can be given on the basis of the aldehyde and ketone which is taken. That is, if our aldehyde is acetaldehyde like this, CH3 CHO, then the product will be in this way. So just need to keep here CH3 and H. So this is the product is ready. Now what is the name given for this product? That is acetaldehyde cyanohydrin, because you are attacking, that is you are doing the addition of HCN to the acetaldehyde. Therefore the product formed, that is called as acetaldehyde cyanohydrin. Similarly, if you are doing the reaction with ketone like acetone, if we particularly we are taking an example acetone, that is CH3COCH3, the reaction with HCN, that means H is positively charged, so you need to attack with the oxygen and you have to attach the CN with the carbon. So that's why you are getting this product. So here you will be having CH3, here you will be having CH3. What is the name given to this product? That is acetone cyanohydrin. So these are the general representation of the reaction of aldehyde and ketone with hydrogen cyanide. So we can say that aldehyde and ketone, that is here generally represented, is react with the hydrogen cyanide, that is HCN, to yield cyanohydrin. This reaction occurs very slowly with pure HCN. Therefore, it is catalyzed by the base and generated cyanide ion first. So first there will be a generation of cyanide ion. Being a stronger nucleophile, readily adds on the carbonyl group, that is on the carbon which get attached to the partially positively charged carbon, because Cn is being a stronger nucleophile. So it readily adds to the carbonyl compound to yield the corresponding cyanohydrin. So this is the reaction of aldehyde and ketone with hydrogen cyanide. Next, that is addition of sodium hydrogen sulfide with the aldehyde and ketone, that we are generally representing in this form, that is in the carbonyl form. Here we are representing the general form here. Now when the reaction of aldehyde and ketone with sodium hydrogen sulfide, formula is NaHSO3, that is sodium hydrogen, this is sulfite, not sulfate, it is sulfite. So the reaction of aldehyde and ketone with sodium hydrogen sulfide, it results in the formation of a product that is an intermediate here. Here this process is taking in this way, that as we know that sodium is positively charged and HSO4 is negatively charged. So the positively charged sodium, that is attack, that is get attached on the partially negative oxygen, and the HSO3 that get attached on the partially positive carbon. So here there will be formation of intermediate in this way. You can see that here is already O and this Na, that is ONA, and here on this carbon atom here O3 is there, therefore OSO2H. So there is a formation of an intermediate. Then because of the proton transfer, we can say that the product which is formed, that is called as bisulfide addition product which is formed. This process is taking place by the proton transfer. What is proton transfer? That means here one Na will be shifted on this side and this H will be shifted on this side. So what will be getting the product? That is after the proton transfer, that is Na and H get transferred, that is Na plus and H plus is getting, they are changing the position and that giving rise to this product, that is bisulfide addition compound that is formed here. So this is the reaction of the aldehyde and ketone with sodium hydrogen sulfide. Now if you want to do the reaction of acetone with sodium hydrogen sulfide, once you have learned this equation, you just need to keep one CH3 and CH3 here. So that will be, here will be, you have to keep CH3 and here also you have to keep CH3. So that is easily you can make the product for any of the ketones and aldehyde once you have learned this general equation. Next is the reaction with the addition of Grignard reagent with the aldehyde and ketones. So here also we are writing the general equation. Aldehyde and ketones reaction with Grignard reagent. Grignard reagent, that is generally represented as RMgX. R is the alkyl group, Mg is the magnesium, X is the halide. That is the alkyl magnesium halide. We have already learnt about the Grignard reagent, that is RMgX. Now here in this also we have to do in the same manner how we have done for the other two cases, that is positive goes with negative, negative goes with positive. So when you look at here R is negative, at the time this one will be positive. Mgx will be positive and R is negative. So the negative is attacking to the partially positive carbon because negative goes with positive, and Mgx that is get attached on the O that is partially negative. So that result in the formation of an intermediate that is formed in this way. Now you can see here R is with the carbon, that is you can see here, and Mgx with oxygen, that is we can write it as OMgX. Now here hydrolysis takes place, that result in the formation of a product that is called as alcohol. How we do the hydrolysis of this? Because we have already learned this equation during the preparation of alcohol. Hydrolysis, that means just need to break this bond, keep one H on the side and keep OH on the side. That is water hydrolysis. So what we get in the product? This side together, that will be one product, and the other product will be, that is the product MgOH X, that will be the other side product. So what is the main product which is formed here? That is actually the alcohol, which is the main product which is formed here. So that is due to the hydrolysis of this intermediate that is giving rise to alcohol. Now this equation we have already discussed in the chapter of alcohol. So if we want to prepare a secondary alcohol, we need to keep here, if we keep acetone here, so what will be getting the product? Will be getting a tertiary alcohol here, because you can see now this carbon is tertiary alcohol because 2 methyl group and 1 R, that is from the Grignard reagent. That means we can prepare a tertiary alcohol when we take acetone. If we take a aldehyde like CH3H, if we are taking acetaldehyde, what you will be getting the product? You will be getting a product that is secondary alcohol, because this carbon you can see 2 alkyl groups are there, therefore it is a secondary alcohol. If you want to take, if you want to prepare the primary alcohol, we have to keep a 2H here. When 2H is taken, that is a formaldehyde. At the time we are getting the product that is 1 degree alcohol we are getting. So in order to prepare the alcohol, we can use the addition of Grignard reagent, we can add to the aldehydes or ketones. So this is about the reaction of aldehyde and ketone with Grignard reagent. Next is the reaction of aldehyde and ketones with alcohol. Reaction of ketone and aldehyde with alcohol. Here also the process is same how we have done for the previous one. That is the positive part and the negative part, because we know that alkyl group is positive, OH is negative. So the positive part will get attached to the partially negative oxygen, and the negative part that is get attached to the partially positively carbon of the carbonyl group in aldehyde and ketones. So in this way, what will be getting the product? That is an intermediate which is called as hemiacetal. It is important word, hemiacetal. So how hemiacetal is formed? When the alcohol get attached to the carbonyl group of aldehyde and ketone. So you can see here the R is that is partially that is positively get charge that is attached on this oxygen, and OH is get attached on this carbon. So this result in the formation of hemiacetal. One more molecule of alcohol is treated in the presence of H plus, then what we getting the product that is acetal. That means this OH is, now that we can say here H is replaced with R. So that is result in the formation of acetal. In acetal you can see 2 OR are there attached with the same carbon atom, that is called as acetal. Now if particularly when we write an example, for example if our compound that is an aldehyde is acetaldehyde, so here same thing you have to write, just only you need to keep a CH3 and H on this side. So you can see here what we called now this one, it is called as acetaldehyde acetal, that is we can call it as acetaldehyde acetal, because commonly we are calling as acetal, but it is we are starting with an aldehyde that is acetaldehyde, then its name will be that is acetaldehyde acetal. Here the acetals are actually gem dialkoxy compounds. What it is called as? Because GEM, gem alkoxy, that is dialkoxy compounds. Why? Because here there are 2 OR groups are there, that is which is called as alkoxy group, that is R is alkyl group and O that is together called as alkoxy. So 2 alkoxy group, therefore it is called as di, and both are attached to the same carbon, therefore we are using the word that is gem. So gem dialkoxy compounds are actually acetals. Next, that is the reaction of ketone with the ethylene glycol. The reaction of ketone that is given here, represented here, RC double bond OR, that is the reaction of ketone with ethylene glycol. This is the formula for ethylene glycol. So the ketone react with the ethylene glycol under the similar condition to form a cyclic product which is known as, that is in the presence of HCl gas and dilute HCl, it forms a cyclic product which is called as ethylene glycol ketal. So this is also one of the important reaction, that is the reaction of ketone with the glycol. Now look at here how this product you can easily frame here. That is 2 hydrogen from here and 1 oxygen, that is removed. So water is removed from here. So what is remaining here? So the remaining part that is this O, this 2 oxygen of ethylene glycol get attached to this carbon. That's why it form a ethylene glycoketal, that is a cyclic compound which is formed, which is commonly called as ketones. So these are the some important reactions that we have discussed here in the form of a general equation. Now you need to give one example of each by keeping aldehyde, a particular aldehyde you can take, that is acetaldehyde, and a ketone you can take, that is a common example of ketone, that is acetone. And you need to write the equation for all these reactions from the general equation to the particular example. So this is all about this video. Have a nice day.